Let's imagine a scenario. Assume you're a chef or an entrepreneur. Then you probably have a dream of starting a new restaurant of your own. And building this huge and fantastic place of yours is your life's hardest work. You put everything you have into this restaurant and voila! Your customers are loving your brand. People are waiting in lines to get your food and services. However, there is a growing problem. When your reputation increases, when your restaurant's reputation increases, the waiting line gets longer and longer, and it creates a headache for your business. So you need to solve this dispute. What would you do? It's a little bit intuitive, right? I assume a lot of you thought about renting another floor or hiring new people or packing the tables so that more customers can fit in. Those are all valid answers. Those are all valid solutions to this problem. The same problem occurs in system design as well, when designing a system as well, aka an application or a website for your customer. As a restaurant has a capacity, applications have a capacity as well. After having reached a certain number of users, applications might stop responding, and we can't afford that. Like, for example, consider Black Friday, consider Amazon.com. During Black Friday, they get like tens of millions of requests in a very short time, and they can't afford any downtime, or they can't stop responding. They must be serving their users 24/7, even if there are millions. So our software systems must be expandable, or in computer science words, scalable. In order to solve this problem, the system should scale up or scale out to solve this problem. So in system design, we have two approaches to solving this problem. The first approach is called vertical scaling. Flashing back to our restaurant analogy, the most logical thing you can do is hire new staff or pack the tables so that more customers fit in, or rent another floor in the same building. So this would be like an easy solution and the most logical solution. This actually is an example of vertical scaling. In computer science world, what vertical scaling basically means is adding more computing power, upgrading a single server so that we can handle the load. By upgrading, I mean like upgrading the RAM or increasing CPU or increasing storage. Those are an example of vertical scaling. When you upgrade a server, it is called scaling up. And this approach has some advantages. The first advantage is lower initial costs. It is usually cheaper to upgrade a part of the system than buying out another system. You can experience this in your daily life. It's generally cheaper to upgrade your computer's memory, for example, than buying another computer. And this is especially beneficial for mid-sized companies and small companies such as startups, since money is a big issue. Another advantage is less complicated maintenance. Let's flash back to our restaurant analogy. Which one do you think easier to maintain and manage? Multiple different branches in various different locations, or one single store? A single store, however large it is generally easier to maintain and manage. When you have a lot of branches in various locations, it's a lot harder to maintain. Consider Starbucks, for example. It's extremely hard to manage Starbucks. Hiring, accounting, the procedures, the communication among branches. It gets harder and harder when you open a new store. Therefore, in vertical scaling, since we are upgrading only one machine and since there is no other machine to maintain, so the communication, the upgrade will be easier to maintain. The other advantage is consistency. Let's use our restaurant example again. Using our restaurant analogy, let's assume you have a formula, a secret formula for hamburgers. It's delicious, everyone loves it, and you want to expand your hamburger business. In which scenario do you think it is easier to retain the taste of your hamburger? When you have multiple stores or in single store? It would be extremely hard to retain the same level of taste when you have multiple branches in various locations, it would be way easier to retain the same level of taste when you have one store. So this is an example of consistency. It's the same in system design as well. When a database is scaled vertically, since there will be no partition of data, data will be eventually consistent. Vertical scaling has proven itself an efficient way of scaling when there is no know-how and there is very little manpower to deal with complexity. Nevertheless, it has serious disadvantages. The worst disadvantage is upgrade limitations. Let's use our restaurant analogy again. When you want to expand your restaurant by renting another floor, but you can't do it like infinitely. You can't just rent another floor infinitely. There is a limit, right? For instance, consider Starbucks. If it had stayed in the same building where it was founded, it would never be a universal brand it is today. Can you imagine how huge problem this is for companies like Amazon and Netflix where they always grow? Here's a fact. Most businesses and systems start up for the whole purpose of growing. And when your business grows and infrastructure doesn't, you'd be out of business very soon. I'm going to give you an example. In 2001, Netflix only had 400,000 paid subscribers. Pause the video for a second and guess how many paid subscribers they have now. Wait for it. 200 million. They have more than 200 million paid subscribers. So they have grown in the 20 years by a factor of 500. So if they hadn't scaled perfectly well, they would have never grown this big. And we probably would not be able to watch Netflix. So therefore, limitations on upgrade is a huge problem for companies, so it's the worst disadvantage. Another disadvantage is single point of failure. Let's flash back to our restaurant analogy. When you have a single store and let's assume an unfortunate natural event occurs, such as an earthquake, and it wipes out entire city, thus your restaurant, and you would lose everything you have. And it doesn't have to be as catastrophic as an earthquake. Even a small fire in an unexpected time could destroy all of your business. Wouldn't it be terrible to lose everything by only one mistake? Can you imagine how big of an issue this would be for big tech companies like PayPal or Google? If PayPal had only one server, vertically scaled, and if an unfortunate event happened, all the money transactions in the world would be frozen. It would be unimaginable. It would be total nightmare. It is the same for Apple or Google or other big tech giants. Therefore, big tech companies avoid single point of failure at all costs that vertical scaling inherently comes with. Another disadvantage is possibility for downtime. Let's use our restaurant example again. When your business goes perfectly well and you want to scale your business, let's assume you want to scale your business vertically and you want to rent another floor in your building. So when you do that, you have to pause your services for a while. Why? Because all of the construction issues, the dust, the noise, the dirt, this would damage your business massively. Your customers would find you reliable, they would go to somewhere else, and you would lose a lot of customers, thus a lot of money. The same issues exist in tech companies as well. Consider PayPal, for example. If they had only one server and they wanted to scale the system, they want to upgrade the system whenever a new chunks of users come to the system or signs up, they would have a lot of downtime, right? Because they always get new users. And this would have some serious consequences and the customers would find PayPal again unreliable. Nightmare scenario. I assume you see where I'm dragging you with these examples. As you guess, this method is not the same method as Starbucks or McDonald's or even Netflix use for expansion throughout the world. So in time, another scaling method developed called horizontal scaling. Back to our restaurant example, horizontal scaling is similar to opening a new branch whenever we want to expand our business. This is how McDonald's or Starbucks has expanded. In system design, horizontal scaling means adding another server to the pool of servers to distribute the load. The load is then distributed, as you see in the image, among multiple servers. In this way of scaling, we have more than one server. The correct term to use is scaling outward, not upward or downward. Horizontal scaling has serious advantages that vertical scaling doesn't have. The first advantage is infinite scaling. So back to our restaurant example, we talked that a single building has a capacity from which you can't scale anymore. And we know the story of how McDonald's has expanded to the world, right? They just open up another branch at another location to distribute the demand to another branch. And this has given them the ability to expand to the world. In this instance, they have no limit on scaling. Again, McDonald's, they're everywhere, right? It's the same in system design. When there is a need for expansion or scaling out, all you have to do is just add another machine to the pool of servers and distribute the load. And you can scale virtually infinitely. The second advantage is fewer periods of downtime. Again, let's consider our restaurant example. When Starbucks decides to open up a new branch in another location, they don't have to close other branches, right? So Starbucks doesn't have any downtime. Always ready, always serving. It is the same in system design as well. So we mentioned in vertical scaling, you may face some downtime while upgrading the system, but in horizontal scaling, since all you have to do is adding another machine, you don't have to close other machines. The system works perfectly well while you're upgrading the system. You may guess how beneficial this is for companies like Amazon, Google, Apple, or Netflix, where they're in constant need for scaling. The third advantage is resilience and fault tolerance. Let's consider our restaurant example again. So we mentioned what happens when a natural event occurs, right? So it would wipe out our whole business. So consider the same scenario. If an earthquake happens at a specific location, for McDonald's, for example, other branches of McDonald's would not be affected by that. So they would keep serving perfectly well. It is super similar in system design. When you have multiple servers for your operations and your data, your system becomes more resilient to failures and errors and natural events. For example, in databases, relying on a single node to store all of your data would be terrible if something bad happens. It would risk losing all of your data. Therefore, distributing the data among multiple nodes prevents losing all of your data. And this is very important, like for companies like YouTube, for example. The last advantage is increased performance. Let's use our restaurant example one more time. The more branches you have, the more people your restaurant is able to serve smoothly. It is the same in systems. When you have more than one servers, there are more than one endpoint, so the HTTP request can land on different machines. Therefore, your system overall is able to serve more people, thus your performance skyrockets. As there is no rose without a thorn, even though horizontal scaling has irreplaceable benefits for businesses, it also has some serious disadvantages. Its main disadvantage is increased complexity. Let's use our restaurant example again. When you have a lot of branches in various locations and when you want to change a single item in your menu, it can be a price of a dish or anything. Even a simple thing becomes a headache, right? It's extremely complicated. You have to do it in every branch you own. Super complicated. Same in system design. When you have a lot of servers, maintenance becomes a serious problem. And on top of that, you need a new piece of software. So this piece of software should be able to direct the incoming traffic to the available computers, to the available servers, like a traffic light. So this piece of software is called load balancing. On top of that, you need other tools such as containerization, virtualization, and some backup software. So it gets extremely complex over time. So another disadvantage is potential inconsistency. So consider a database. When a database is scaled horizontally, when another server is added, so the data is split between partitioned among nodes. So the data will be inherently partitioned and will be inherently inconsistent. So you need tools again to deal with these problems. So there is a solution to this problem, but again, there's always a possibility to corrupt your data. It requires serious expertise. So to sum up, when your application has grown big enough, always better for your application to be scaled properly. And if your application does not scale properly, this may damage your business. So we mentioned the techniques to solve scalability problem. One is vertical scaling, the other is horizontal scaling. Even though which technique you choose matters a lot, but the message is still clear. Your application should be scalable no matter what.